Okay, so the James Webb Space Telescope spotted something cool, what looks like light beams from a city way out in space. This discovery has, totally gotten people excited about aliens again. The telescope was checking out Proxima Centauri b, which is the closest planet outside our solar system, and it saw some weird, bright flashes. Could they be signals from an alien civilization? We'll have to wait and see. People have been dreaming about life on other planets forever. Any little hint gets everyone pumped, but when the James Webb Space Telescope showed some pretty clear signs of life, it was a big deal. While scanning the skies, it saw lights on a distant planet that looked like city lights. Maybe there's an alien metropolis out there? This idea has scientists super hyped, hoping for that discovery they've been waiting for. It suggests there might be smart beings doing stuff we can only begin to imagine. These city-like lights are really far away, like 4 light years. NASA folks were blown away, wondering how long these signals have been floating around, waiting for us to get the tech to see them. David Kipping, an astronomer at Columbia University, said the planet where they saw the lights is super strange. Unlike most rocky planets that just soak up sunlight and spit out heat as infrared, this one acts differently because of how it hangs out with its star, Proxima Centauri. This discovery shows how awesome the James Webb Space Telescope is. It can spot infrared light, which was key to figuring out what's up with Proxima Centauri b, giving us a peek at the planet's atmosphere. Researchers will keep using the telescope to take a closer look at the atmosphere, hoping to figure out if it's a place where life could exist. The James Webb Space Telescope is really good at seeing infrared stuff, so it can check out Proxima Centauri b even at night. Most telescopes struggle to see faint signals in the dark, but Webb is a pro at picking them up. That makes it perfect for confirming if those alleged city lights on Proxima Centauri b are legit. The telescope can spot artificial light as long as it's in a specific frequency range, much tighter than the light from normal stars. Proxima Centauri b and its star have a weird relationship that messes with the planet's surroundings. Like many planets, it gets a ton of energy from Proxima Centauri. As it goes around the star, it has day and night cycles, just like Earth. But Proxima Centauri b gets super hot during the day and freezing at night. This temperature swing is wild because of what the planet is made of. If it has an atmosphere, the temperature difference between day and night would be crazy, with one side burning up and the other freezing solid. This extreme temperature change is something astronomers are checking out because it could tell us a lot about the planet's atmosphere. The James Webb Space Telescope, with its infrared skills, can check out the planet's heat coming off it, giving us even more info about its atmosphere. Here's a cool thing. The James Webb Space Telescope orbits Earth in sync with Proxima Centauri b's orbit, so scientists can track the planet's daylight cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step is to figure out what's in it to see if it could support life. Finding stuff like oxygen, water vapor, and methane would mean the planet might be able to sustain life. The James Webb Space Telescope is great for looking at planetary atmospheres, but it's not perfect for everything. It's awesome at spotting water vapor, carbon dioxide, and methane, but not as good at finding free oxygen, which is a key sign of life. Still, the telescope can look for other clues, like ozone, which means there's a healthy atmosphere. As scientists dig into the data from the James Webb Space Telescope, the hunt for other worlds is still on. This is getting us closer to answering that big question, are we alone? Keep in mind that the James Webb Space Telescope can only see a few planets close to Earth. For a really good look at planetary atmospheres, astronomers will use ground-based telescopes like the Extremely Large Telescope, ELT, which should be up and running in 2027. The ELT is designed to zoom in on the atmospheres of distant planets, giving us better info on whether they could support life. People are stoked for the launch of future space telescopes like the ELT. Meanwhile, the James Webb Space Telescope is still super valuable for checking out distant planets. Even with its limits, it's giving us important info that could totally change how we see what's out there. Researchers have big plans for future space telescopes. These new gadgets will have tech that cuts down on starlight, so we can see the faint light bouncing off planets better. It's like using your hand to block the sun so you can see. These new telescopes will block bright starlight, making it easier to study the light from distant planets and figure out what their atmospheres are made of to see if they might have life. But it's not easy. Stars are crazy bright and usually outshine the planets around them, making it tough to spot the faint light from planets. To fix this, scientists are working on cool tricks. One is the coronagraph, which sits inside a telescope and blocks starlight while letting planet light through. By messing with the light waves, coronagraphs can dim the star, making it easier to see the planet's faint glimmer. Another cool idea is the Starshade, a giant flower-shaped spacecraft that will fly way out in front of a telescope. The Starshade blocks starlight before it hits the telescope, so only light from planets gets through. This could be super helpful for seeing planets in the habitable zone where liquid water, and maybe life, could exist. These high-tech things need to be super precise. For example, a star shade has to be aligned perfectly to within tiny fractions of a millimeter over huge distances. Plus, these innovations have to deal with the challenges of space missions, like being small, using energy efficiently, and surviving the harshness of space. Despite the difficulties, the potential payoff is huge. If we can successfully see and study the atmospheres of planets, we might find biosignatures, chemical signs of life, like oxygen, methane, or water vapor in certain amounts. These molecules could mean there are living things out there. Researchers are also figuring out how to take direct pictures of distant planets in more detail. Future telescopes might have advanced adaptive optics, which fix distortions from Earth's atmosphere or the telescope's movements, giving us sharper images. Combined with starlight blocking tech, these improvements would let scientists not only spot planets but also map their surfaces and study their climates. This kind of imaging would be a giant leap in our ability to study planets and decide if they could have life. Building these next-gen space telescopes is a major step in our search for life beyond Earth. By getting better at seeing distant planets, we're getting closer to finding out if we're alone, which could totally change how we see our place in the universe. The search for life is moving fast. As scientists dig deeper into the mysteries of distant planets, the James Webb Space Telescope is leading to a cosmic discovery. The info. The James Webb Telescope is great at picking up infrared light, so it can see Proxima Centauri B even at night. Other telescopes struggle to see faint signals in the dark, but the Webb Telescope is awesome at finding even the dimmest lights. This makes it perfect for confirming if those city lights on Proxima Centauri B are real. The telescope can spot artificial light in space if it's in a very specific frequency, much narrower than the light stars let off. Proxima Centauri B is closely tied to its star, which impacts the planet a lot. Like other planets orbiting stars, it absorbs a lot of energy from Proxima Centauri. As it goes around its star, it goes through day and night cycles, just like Earth. The temperature on Proxima Centauri B changes a lot, mostly because of what it's made of. If it has air, the difference in temperature between day and night would be huge, with one side burning hot and the other freezing cold. This big change in temperature is important for astronomers to study because it tells them about the planet's air. Because the James Webb Space Telescope can spot infrared radiation, it can check out the planet's heat and learn more about its air. The way the James Webb Space Telescope orbits Earth lines up with Proxima Centauri B's orbit, letting scientists watch the planet's daylight cycles every 11.2 Earth days. If Proxima Centauri B has air, the next step is to figure out what chemicals are in it to see if it could support life. Finding things like oxygen, water vapor, and methane would be a good sign. While the James Webb Space Telescope is great for checking out planetary atmospheres, it's not able to do everything. It's good at finding water vapor, carbon dioxide, and methane, but not as good at finding free oxygen, which is important for life. Still, the telescope can look for other signs like ozone, which suggests a healthy atmosphere. As scientists look at the data from the James Webb Space Telescope, the hunt for planets keeps going. This is bringing us closer to answering the big question of whether we're alone in the universe. It's worth noting that the James Webb Space Telescope can only look at a few exoplanets close to Earth. For better studies of planetary atmospheres, astronomers will use ground-based telescopes like the Extremely Large Telescope, ELT, which should be up and running in 2027. The ELT will let us look closer at the atmospheres of faraway exoplanets, giving us more accurate data on whether they could support life. People are excited about future space telescopes like the ELT. In the meantime, the James Webb Space Telescope is still super important for checking out distant exoplanets. Even with its limits, it keeps giving us important info that could change how we see what's out there. Researchers are planning more space telescopes for the future. These new tools will have tech that reduces interference from starlight, letting us see the dim light reflected by exoplanets better. It's like using your hand to block the sun so you can see clearly. These telescopes will block bright starlight, making it simpler to study the light reflected by distant planets and figure out what their atmospheres are made of to see if they could support life. But this isn't easy. Stars are really bright and often brighter than the planets around them, making it hard to spot the faint light that planets reflect. To get around this, scientists are working on new ideas. One idea is the coronagraph, which sits inside a telescope and blocks starlight but lets the planet's light through. By shaping the light waves carefully, coronagraphs can make stars much dimmer, making it easier to spot the faint light from planets. Another cool idea is the Starshade, a big flower-shaped spacecraft that will fly in front of a telescope, thousands of kilometers away. The Starshade blocks starlight before it enters the telescope, letting only light from exoplanets reach the instruments. This could be really useful for watching planets and their stars, where water and maybe life could exist. These new technologies need to be super accurate. For example, the alignment of a starshade has to be perfect to fractions of a millimeter over huge distances. Also, these things have to be small, use energy efficiently, and handle the harsh conditions of space. Despite these challenges, the rewards could be huge. Successfully watching and studying the atmospheres of exoplanets could lead to finding biosignatures, chemical signs of life like oxygen, methane, or water vapor in certain amounts. These molecules could mean there are biological processes happening, suggesting life exists beyond Earth. Researchers are also looking at ways to directly take pictures of distant exoplanets in more detail. Future telescopes could have advanced adaptive optics, which fix distortions caused by Earth's atmosphere or the telescope's movements, making images sharper. With starlight blocking tech, this would let scientists not only find exoplanets but also map their surfaces and study their climates. This kind of imaging would be a big step forward in our ability to study exoplanets and decide if they could support life. Building the next generation of space telescopes is a big move in our search for alien life. By getting better at watching distant planets, we're getting closer to finding out if life exists somewhere else, which could totally change how we see our place in the universe. The future of space searches and the hunt for alien life is going fast. As scientists and astronomers dig into the mysteries of distant exoplanets, the James Webb Space Telescope is leading the way in cosmic breakthroughs. The data it gathers is helping astronomers find big things about the structure, what they're made of, and if far-off worlds could support life. With each new piece of info, we get closer to answering the big question, is there life beyond our planet? The discovery of Proxima Centauri b is just the start of what could be a key moment in our exploration of alien life.